Are you ready for the 2001 FRQ? I hope so. We're going to take a look at the 2021 set number one FRQs. Just doing one set from each year here. This FRQ, in my opinion, it's not as crazy as the last couple of years. This is the first year post-pandemic where they had an on-paper test. And we're going to do the 5 minutes per problem, roughly, and then take a look at the solutions to see how many points we can crank out in that time. But, I would say that the last 2 years have been pretty crazy. This one's starting to get there, but it's not as bad as the more recent years. We'll see some of that. My students did not take this test. In 2021, we were taking the digital test, which is all multiple choice, which kids said that they loved at the time. I don't know if they loved it once they got their scores, but you can't go back on the digital test, unfortunately. So anyways, let's take a look at this one, do a little 5 minute and see how we can get. All right, so it says 0.5 kilogram fan cart is placed on a level horizontal track. I'm looking at this and I'm thinking this has got to be some sort of conservation of energy thing, maybe? I don't know, there's a hill going down, but there's a fan cart, so there's gonna be some forces, there's an angle. If they give us an angle, they might want us to do net force equations, but I'm getting ahead of myself. Let's read what they actually tell us to do. Fan is turned on, the cart is released from rest. Okay, that's good. A cart travels on a horizontal track down an incline. Motion detector 1 measures the acceleration of the cart from time 0 to time 3 seconds. And at time 3, the cart makes a smooth transition to the incline. The motion detector 2 measures the acceleration after time 3. Fan exerts the same magnitude force, 20 at a time. Okay, so I'm looking at the graphs here. There's no questions yet, so I guess that's on next page. There's a positive acceleration for being on the horizontal track, but then it's negative down here. It's negative down here because you're getting closer to the sensor. You're going in its negative direction, but everything's going downhill, so we can decide what to do with that later. But let's see what question 1's asking us. It says, on the dots below that represent the carts, the two different free body diagrams. Okay, cool. Let's do it. Free body diagrams are always good. You should be able to get some points there. So I'm going to have mg, or you can write F sub g, should be normal force. And on the horizontal track, there's just the fan, right? So, oops, not F normal, F fan. And then on the incline, there's still going to be an mg. And the fan's still going to be pushing downhill now. And there's still a normal force. I think that's it. It says there's no appreciable friction. B, calculate the magnitude of the net force exerted on the fan cart on the horizontal track. All right, so let's look for forces. Again, we're not going to do the whole completion here, but on the horizontal track, that's just going to be the fan. There's no friction, right? And that should be equal to m times a. So, yeah, that's all we would have to do there. All right, part C, calculate the angle of the incline. So again, it looks like they want us to do not conservation of energy, but dynamics equations. So I would say net force on the incline would be the fan's pushing downhill, and then mg sine theta, sine components, the sliding components going downhill, no friction. So that's all equal to m times a, and the acceleration is downhill. Again, here, it's like they gave it to us as all negative, but we can choose our own direction. Let's use the magnitude of the numbers. And from this, we can solve for that, if we know what those values are. Okay, that's set up. D, we've got 2 minutes left and we're already on part D. This is very unlike the other 2 years. Suppose after careful measurement determines the angle to be 3 degrees larger than the calculated amount. And they explain it by saying the scale used to measure the mass of the cart was not calibrated properly before the measurement. Does that explain it? I would say probably not, but I think we'd have to solve this stuff before we can do it. So we could make a guess, but let's not make a guess. Let's see if we can get some other parts set up. Oh, beautiful. Draw a best fit line and use the straight line. You know what this is. Draw a best fit line, no problem. Gotcha. Line, of course we would do a better job of it. And then how do you use a straight line to figure something out? You calculate the slope. And to calculate the slope, we can say it's going to be the change in whatever our vertical axis is divided by the change in our horizontal axis, set that up so we know what to calculate later, but I mean, we should be able to do that. And then part F, if the cart were replaced with a second cart of mass 1 kilogram and it has a fan that exerts the same magnitude, how would the graph change? Okay, we need to do a lot of stuff before we can figure that out, but it hasn't even been 5 minutes yet. I mean, I kind of cranked through this. You guys would take longer, I'm sure, but for this one, what's this asking for? What's the net force? Let's see if we can get some calculations in. The mass was 0.5, and what's the acceleration on the graph here? It's a weird setup. That's 0.2345. So 2 divided by 5 would be 0.4. So each of these are 0.4. So that's 0.8 acceleration. Okay, so I'd have 0.5 times 0.8. So that'd be 0.4 newtons. All right, we got some. What do you know? My 5 minutes is up. So I got a bunch of stuff done, and then we get kind of stuck there. So I would say that with the time we have, I mean, you're gonna plug that into there and then solve for theta. So, sorry, we're getting ahead of ourselves. Let's go ahead and take a look at what the solution should be. Let's pretend we couldn't do any more in that time. What did we get in 5 minutes? Let's take a look here. Pull up the rubric right here. Let's go up to part A. Sorry, let me shift this over. Oops. There we go. So the free body diagram, how did we do? It says for correctly drawing and labeling all forces on the cart on a flat surface. Okay, that's one. So all 3 forces. Correctly drawing and labeling the weight on the incline, 1 point. So I guess it's all of this together has to be right to get the points for correctly drawing and labeling the normal force on the cart on the incline. Oh wait, no. So flat surface one, you have to do all of those correctly to get 1 point. Okay, so the way they describe this stuff is a little tricky. So that's +1, all right? We got the weight and the normal force correct, so that'd be another 2 points. And then for correctly drawing and labeling on the so 3 points for the incline one. Jeez, okay, we'll take that. So 3 points on the incline, so that's 4 points just for doing the free body diagram. We'll take it. And then they put some clarifications, but I'm going to say we did it correctly. B, it was supposed to, you get 1 point for doing Newton's second law. Okay, cool. So, I mean, I guess we could have labeled this a little bit better, but +1 for that. And then getting 0.4 newtons. Correct answer with units. We did it. We put 0.4 newtons. That's another point. I'm liking this FRQ. Let's see what we did on D. We didn't answer D. I'm sorry, C. My mistake. I wrote that answer on there. Oops. That's +1. C, what did we get for C? For including the correct components of the weights, so mg sine theta in a Newton's second law equation. So writing that out, we put A instead of A2, but I'm trying to write it quick here. I think that's worth a point. For correct use of Newton's second law equation, 1 point. Wait, for putting mg sine theta, it's a point, and for putting Newton's second law, it's a point. Really? I'm loving this FRQ. And then for correct substitution okay, so yeah, if we subbed this in and solved it and we got 9.4 degrees, we'd get an answer. Cool. Then for selecting no, we didn't do this part. So it evidently, right here, the mass, well, the fan, I saw this one coming here. The fan cart was m times the original acceleration. So there's still an m in here. So the m's cancel out. So mass has nothing to do with it. So yeah, anyways, read through that later, please. Then part E, EI and EII, for drawing an appropriate best fit line. Mine's actually not terrible from what they drew for drawing it in half a second. +1. Man, loving this FRQ. Got a +1 there. For correctly calculating slope using 2 points from a best fit line, we did not actually calculate the slope, so we don't get that point. But if you spent just a little bit longer on the problem, you would have got that point. All right. And then F we didn't do, and then it goes on to the next problem. So let's count how many points we got here. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 points? That's not bad. Let's see what the average was. The mean value is 9.31. 15 minutes on a problem, and people on average scored 9.3 points. We got about 9 points. We got almost the mean value just spending 5 minutes on it. Now, again, people fluctuate in what they can and can't do in that stress of 5 minutes, but I think with another 5 on top of it, you could have eked out about 10 or 11 points on this question. It's a pretty good one. Okay, we'll wrap that up and we'll go on to number 2.